How is this pilot landing under such foggy conditions? No visuals, no runway, just thoughts and prayers.
In reality, pilots land using an avionics system, known as the Instrument Landing System, or ILS. So instead of guessing, we will show you how to land a Cessna 172, using the ILS in MSFS 2004. First, let's look at how the ILS works. The ILS consists of two systems: the localizer transmitters on the ground near the end of the runway, and the glide slope transmitters at the side of the runway. These signals are displayed on the cockpit's course deviation indicator. For the localizer, the vertical needle on the CDI shows whether the aircraft is left or right of the runway centerline. For the glide slope, the horizontal needles show whether the aircraft is above or below the glide slope. The glide slope is the descent path that the aircraft follows. When both the vertical and horizontal needles are centered, the CDI should appear like this, indicating that the aircraft is on the correct approach. As the aircraft continues on the ILS approach, marker beacons provide distance checkpoints along the runway centerline. Passing each beacon triggers a light and sound in the cockpit, telling the pilot roughly how far they are from the runway. Now let's look at the procedures to use the ILS. Welcome, recruits. I am Captain Lee. Today, I will teach you the procedures to use the ILS. Before we begin, we shall look at our flight plan as an example. We shall start the flight at this position and fly to the final checkpoint to prepare for landing. To do so, we can use the GPS to fly to the final waypoint. Simply align the aircraft's heading with the route line shown on the GPS. Continue flying till you reach the final waypoint. Once we are at the final waypoint, we should begin the approach. First, let's refer to the WSSS Aero 2L chart that real pilots use. The Aero 2L Changi runway that we are landing on has a heading of 23 degrees, interception altitude of 2,500 feet, and frequency of 110.9. Input the frequency 110.9 in the radio panel, on the very top right. Click the STBY button and ensure the number beside it is changed to 110.9. The CDI needles should be non-centered now. Next, we will input 2,500 feet in the autopilot using the radio panel. Then set the heading bug to 23 degrees. Finally, press the HDG and ALT button. This will allow the autopilot to descend to 2,500 feet and turn to 23 degree automatically. Now observe the altimeter and heading indicator changing. Now we should be in range of the LOC and GS, and we shall begin the manual approach. First, disable the autopilot and fly the plane manually. Focus on the CDI and try to align the LOC and GS needles. Since the LOC needle is on the right, it means that the aircraft is off-centered to the left. To center it, we need to gently roll the aircraft to the right. Observe the needle moving towards the center, and keep making small and precise roll adjustments till the needle is centered. If your needle is on the left, simply follow the same steps but roll left instead. Similarly, since the glide slope needle is above the center, it means that the aircraft is below the GS. To center it, you can throttle up or pitch up. Use throttle for large adjustments and airspeed control, and use pitch for small adjustments. Observe the needle moving down, and continue to make adjustments till the needle is centered. Again, if your needle is below the center, follow the same steps but pitch or throttle down instead. Now you may ask me, can I align both needles at the same time? Don't worry, let me answer your question. A common mistake is trying to align both the needles at the same time. This causes the needles to overcorrect or misalign, and it's simply too many tasks to juggle at once. Instead, align each needle one at a time. Now, I bet you are also wondering, what should I do if I already overcorrected the needle? Another mistake is adjusting too much movement at once, which causes the needle to overcorrect. To fix this, gently roll back and make gradual corrections. A pro tip to avoid this would be to apply a counter. Input when the needle is near the center, aka a reversed roll, pitch, or throttle. For example, if the original input was pitch up, we will pitch up slightly, then pitch down again immediately. Finally, one question beginners always ask me is, what's the difference between using throttle and pitch for aligning GS? First, we should use the throttle, as it makes the aircraft climb or descent back on the GS. Once we are almost aligned, we should use pitch to make fine adjustments. This speeds up the process, while reducing the chance of over or under correction. Always remember, throttle for path and pitch for precision. Next, notice how the ILS middle beacon is alerting us. Note that this runway only has a middle beacon. Now that our needles are aligned, we can begin with the next step. To slow down, reduce throttle gradually. Avoid pulling power too quickly as it can destabilize the aircraft. Then increase the camber of the flaps as the speed decreases. A safe speed for touchdown would be around 80 knots. Flaps increase lift and drag, allowing the aircraft to slow down while avoiding stall. This balances the aerodynamic forces, lift, weight, drag, and thrust, keeping the aircraft stable on approach. Now let's look at a bad example of what not to do when reducing throttle and using flaps.
If flaps are extended without slowing down first, the aircraft becomes unstable and pitch up due to extra lift. Likewise, slowing down without configuring flaps can reduce lift and make the aircraft pitch down. See how the aircraft pitches down after I reduce speed without increasing flaps? Now I have to pitch up to correct for that, which introduces more workload. Instead, you should only gradually increase the flaps as the speed reduces.
Lastly, if your airspeed is too slow, you might stall.
Oh my God!
To avoid that, try to keep the speed not lower than 60 knots and use flaps appropriately. Similarly, if your airspeed is too high, you may overshoot the runway or bounce up and down upon contact due to high lift. Now just continue adjusting flaps and throttle and make sure the speed is okay. Once we are near the runway, we can begin the next step.
At this stage, the goal is not to chase the needles, but to maintain a stable approach with small, smooth corrections. As we cross the runway threshold, we gently reduce throttle and begin the flare. The flare slightly raises the nose, reducing the rate of descent, allowing the aircraft to gently touch down. Now let's look at our landing from the side view. Note how the nose pitches up very slightly. Next, let's look at some bad landings. Notice how the plane bounces up and down. This is what happens when the descent speed is too fast, and it's usually due to landings with no flare or a late flare. Finally, let's look at what happens if we flare up too much instead. Notice how the plane is floating and struggling to touch down. This is usually due to excessive lift, which results in the aircraft staying level or even climb. This is caused by excessive flaring. Note that this is not the same as the bouncing phenomenon, as the aircraft does not make contact with the ground in this scenario. Congratulations on your first rodeo, recruit. You have completed the ILS training. Remember, practice makes perfect. Keep practicing your landings to sharpen your skill. Here's a quick checklist you can use for your practices.